Good morning, good evening, good night. I don't know, and I always said all the goods, all the possible goods, because at the end this is an online session, so you can be in any on time zone. So today we're going to start with the Kubernetes Master course number 2. Okay, this is the continuation of the previous course, the one that we've got on Monday, and as usually, let me share with you all the links. This is the links for the tutorial. Remember that everything that we are showing to you are in this tutorial, so you can follow at home or at work after the session. And also I'm going to share with you the slides. There is not going to be a lot of slides today, but just in case you want to follow them, they are here. So let's start. Okay, so let's start. Remember that today is Wednesday, we're doing this Kubernetes Elementary, but the next week, same time, also except in the French time zone, I guess, we've got the Kafka course and the Istio course. So Monday, if you want to learn about Kafka, then this master course is for you. And the next Wednesday, if you want to learn about Istio, really cool advanced topics about Kubernetes, then this course also is for you. And by the end of July, you will be able to learn Tekton. Tekton is a CI/CD tool that is Kubernetes native, so you can just integrate into your Kubernetes cluster all the continuous integration, continuous deployment, continuous delivery thing. So, as a reminder, my name is Alex Soto, my Twitter is AlexSotoB, my email sotob@redhat.com. If you got any question, you can ask me on the chat that you've got on your right, or you can send me an email or just a tweet. So today we're going to see how to build image, the resource limits, rolling updates, how to do a rolling updates, liveness and readiness proofs, and environment and config map. Then today, before we start with all these topics, let's see how we can do a rolling update, or what's happening if we do a rolling update without doing anything at all, just doing a rolling update. For the reason, now I'm going to start Minikube. You can see that I'm starting here a Minikube, so I'm just on my local machine. I've got here my cluster. If you get nodes, you can see that here I've got my OpenShift cluster in Frankfurt, which is running bad in this time, so you can see how to work with Minikube. We're going to run this demo in Minikube. Notice I'm starting Minikube. It starts fairly fast, maybe just 1 minute or so. And notice that the important thing is that I'm just doing this -pcube, because Minikube allows you to create profiles. So you can have many clusters. Even you can create several clusters at the same time and do some kind of multi-cluster or hybrid cloud. Buenos dias, Oscar. Let's see if it starts. Notice that in this case I'm using the Kubernetes 1.17.3, but that's fine. And notice that it's pretty fast. Then I can do kubectl get pods. And the important thing here, well, now it's erroring. Now it's running. I've got here three instances of three instances of my boot application. And if you are curious of if I'm really in a Minikube, I can do kubectl get nodes, and notice that here it's saying that there is only one node. Meanwhile, here it says that I've got worker node and master node. In case of Minikube, you just have one master node. This has changed recently in the latest versions. You can create even worker nodes in Minikube with some kind of flags. Okay, but for now, let's assume that Minikube is just a single node. So now here I can just do a curl to these services. The problem is that how I can do a curl to a Minikube, because Minikube is not exposed to a public API, it's my private API. So the first thing that I need to do is check the services. And notice that I've got here my boot service with a cluster IP and here the port. Okay, I've got the exposed port and the port binding. Now, to know the IP where I need to connect, I need to do a minikube IP, and it gives me an IP. So I need to do a curl to this IP and this port. So I can do curl to this IP and this port. Oops. Now, and see that I said Aloha from a Spring Boot. Okay, now to make things more interesting, I'm going to do while true, do curl sleep done. Okay, so I'm just simulating that I've got several concurrent users accessing to my service, my boot service. Okay, notice that it's iterating all the time. And now I'm going to do an update of this application going from version 1 to version 2. So I'm going to do kubectl edit, deployment, my boot. We already done this in the basic tutorial on Monday, right? And I'm going here, but now instead of changing the replicas, I'm going to change here the image. I can just change this to v2. And now the important thing is before I save this resource and it starts the rolling update, you need to see all the time, put your eyes on this bottom terminal, okay? I'm saving, now I can do a watch. Notice that it's doing the rolling update. And notice that I'm getting some kind of downtimes, right? I'm just getting connection refuse. And then after some time, sometimes it's like 1 second or so, or 2 seconds, I'm starting again getting good response. And notice that now I've updated because instead of saying Aloha, it's saying Bonjour, because Bonjour is the message that it's returned in version 2. Okay, so notice that, okay, that's really cool, right? But there is downtimes and we do not want downtimes. So if you want to know how to fix this in Kubernetes, stay in the course because we're going to see later how to fix it. So now that I finished this, notice that finally the running update finished and we've got the new versions running. And now I'm going to stop minikube because we are not going to require it anymore. The purpose of this example is just show you that you can use minikube, and if you want to access a service in minikube, you need to do it in a different way as there is no public IP. Okay, so you need to do this minikube IP and then get the port. Okay, now I can just stop it. Again, I need to stop it using the minikube stop -pcube, and then the minikube just stops, and now I do not have my nodes up and running anymore. Okay, so I'm just switch back to my OpenShift cluster. Remember that the OpenShift cluster at the end is just a Kubernetes cluster because OpenShift is it's an implementation of Kubernetes. And okay, we can start now. Let me go to the slides because one of the things that we want to fix in this course is how to build images. Okay, how we can build the container images to run inside a Kubernetes cluster. But before, remember, Kubernetes is trying to, or the challenges of the Kubernetes is to make containers scalable, so we can scale containers, move them to different machines, and in a really clean way. We've got the pods, we've got the replica sets and deployment. Remember that replica sets and deployments are the processes who is in charge of checking that the state of the services are okay. So if, for example, we said that we want 3 instances and at some time one of these instances dies, then Kubernetes automatically starts a new instance. In this case, a new pod. Remember that the pod is like a virtual machine. It's the new virtual machine or virtual machine 2.0. Okay, we've got the services which gives us a static IP for the pods because pods, the IPs are dynamic. We've got persistent volumes and we've got labels. So how we can build images, as you might know, to create a container image, you need to craft your Docker file, right? So you need to create a Docker file where you define all your dependencies, all your base image and so on, all the stuff that you need to do. Then you need to do Docker build and you create this build. Probably if you are using a remote cluster, you need to do a Docker push. Basically, you need to have a registry of containers. You can use Docker Hub, you can use Quay, which is from Red Hat, etc. So this is up to you. And then you need to do a kufctl apply of the deployment, kufctl apply of the service, and check the URL, right? If you are into, as I said, if you are into the Minikube and the min volume, let me check now. Wait. Now. I think it's okay. Yeah, I think that now it's okay. I'm checking the bar and it's rising correctly. It's almost on the yellow side, so it seems that it should be okay now. Okay, thanks. So if you are in the Minikube, since you don't need a public registry, you can do an eval of Minikube minus the profile and Docker M, and then you can just do Docker build, and this Docker build happens inside the Minikube. Okay. So let me show you how we can start building the an image, and so let's start watching some code, which is here. CD apps, hello world, Spring Boot. Okay, I'm just going to start this application so you can see how it works, and at the same time I'm going to start Docker, because at the end creating a container image, a Docker image, you can use, for example, Docker for this purposes. Of course, it's not the only way of doing it. There is some kind of great technology that allows you to create Docker images in a Dockerless environment. I think that we've got no slides here. No, it has been removed. But the thing that you need to know is that it's here. Yeah, it's here. You can see this slide, which is a skip, but I can show you. Let me skip it. But basically, you can create a Docker image with Docker build, but also you can use Dockerless approach. So it's approach that you are creating Docker images without using Docker. And for example, if you are in Java, there is the Zip plugin that works pretty well in case of Java. There is the S2I. Also, there is Podman, Kaneko, Makisu. All these technologies are not using Docker to create the Docker images, and that's perfect when you are inside a Docker environment. So if you want to create a Docker image without having Docker installed or running inside Docker, then you need to use any of these technologies. But for now, let's keep things simple, and let's see here. I've got my application. This is the application that we have seen several times these days, where we are just returning when I'm going here, when I'm going to doing a request, I'm just getting the host name, notice the greetings from Spring Boot count on hostname. Okay, this is the application that we have seen just this morning, or this the initial of the class. And then we've got a Docker file when I'm saying, okay, I want to use one Docker image. This Docker image is the as a base image, which is the one from Java. And then I'm just setting what is my runnable, my working dir. I'm copying the app jar, so I'm copying the jar inside the Docker container. I'm exposing the port, and finally I'm just running the application. This is how I define how my container must be created and must behave at runtime. But now let's, for example, change something here. For example, I could say this from Spring Boot 2. Okay. Now, what I can do here is just do a mebon compile package minus the skip test, for example, to just create a jar file. Now I could just do java minus jar target. Notice that now I'm not inside any container, inside nothing. I'm just running local program. Okay, I can do java minus jar, then Spring Boot starts, and I can do a curl to localhost 8080. And of course, I'm just getting Jumbo from Spring Boot 2. This is the 2 that I've added on unknown, because when it's in localhost, there is a known host name. Okay, now what's happening if I want to create a Docker image? Then I need to do a Docker build of this Docker file, the Docker file that we've got here. So I can do Docker build. minus t. Let's call it, for example, yeah, before it's okay. You need to set the public registry location. In this case, I'm just using quai.io. This is a Docker registry. This is the host name of the Docker registry. And I can just say then the group, developers. I need to set a group. Usually this is, for example, your company name. And then I need to add, let's say, the artifact ID, which is the name of the service, in this case, my boot. And finally, after the colon, I need to add the attack. In this case, usually it's the version. And dot, because this is where I have the Docker file. So I just run it. Notice that I executed all these steps. Step 1, I downloaded this image, then I get it, the environment variable, I change the work dir, copy the jar file, etc., etc. So I just create it and finally says successfully tag image. So if I do Docker images, you can see that one of the first images that are in this list was created 22 seconds ago, and it's this image, right? The one that I've created. Now I can just do docker run minus t minus rm, and then minus p 8080 quai.io /rh developers /myboot before. Now again, I'm running this application, but inside a Docker container, and I can do I can do curl localhost 8080, and notice that now I'm just running my container on my local machine, and I'm just getting the result of the change. Notice I'm getting Jumbo from Spring Boot 2, 1 on, and now I've got a host name because now my application is running inside a host name. Okay, now let me start this container in another way. Basically, I'm going to show you how you can limit the resources that a Docker container can use inside a Docker environment. I know that probably you are saying, why are you explaining me this? Please get a bit of patience, because you're going to see it in a few moments why this is important and how affects in the Kubernetes. Okay. Okay. Then what we can do is just, as I said, docker run minus t minus rm minus m. I don't know, minus m, no. Yes, minus p 8080 minus m. This is for the memory, which is 4m. So I'm just limiting the container, saying you can only use 400 megabytes of RAM, only one CPU. Okay. And then I need to do quai.io /rh developers /myboot before. Yeah. Now I'm starting again this application. I can do a curl again. Oops, it's starting. And there we go. Okay, now it works. But remember that I said that my container can only use 400 megabytes of RAM. Okay, but now I've got a new special endpoint here, which is called sysresources, that tells me how many resources this Java application thinks it has. And notice that it says I've got 2 gigabytes of RAM and 4 cores. And you might say, why are these numbers? The reason are here. If you check my preference, my Docker host, now I'm opening the preferences, you'll see here that I'm using 4 CPUs and 8 gigabytes of RAM. It means that Java, by default, if you do nothing, they do not care about containers. They just go to the bare metal machine, in this case this virtual machine, and said, okay, I have 8 gigabytes of RAM, so I'm going to use 1/4 of the memory, in this case 2 gigabytes of RAM, right? So now Java is using more memory than the one that we specified in the container. So what's happened when I start consuming this memory? Let's do a consume. Consume is just a method that start consuming, generating random strings, okay, consuming more and more memory. Let's do it. Let's run it. You see that it takes a lot of time, but the important things are here, up here. Let's wait like 1 minute. I don't know if there is any question. Meanwhile, Minikube supports in Windows. Yes. Can you please increase your mic volume? I think that I've already done. Okay, perfect. Now it's still consuming memory. And notice what's happened. The container was killed. The reason that it's killed, the container, is because we have go beyond the memory that we assigned to a container. Remember that when I've done this Docker run, I said I want to use 400 megabytes of RAM, but from the Java point of view, I'm using 2 gigabytes of RAM. So I start consuming, and when I reach the point where I consumed the 401 megabytes of RAM, then the Docker host killed my container. And this is also happening in Kubernetes. This is why I show it you here, but in Kubernetes happens the same. The good thing is that in Kubernetes, since there is the replica set, the deployment, it's automatically started a new pod. So the pod is killed because of OOM, out of memory, and then the system just restart, right? For this reason, when we are into Java world, into JVM world, not just Java, Kotlin, Groovy, and so on, or any technology which are not aware that it's running inside a container, we might have these problems, that we added some resources, some constrained resources, but when we are running them, they are overwhelming these processes. Then, how we can fix this in Java? Well, let me show you. Let's go here. Here, we have 2 ways. One way is just using JDK 11. With JDK 11, which is not the most used version out there in Java, the most used is Java 8. This is fixed. Okay, this is one way of doing it. Another way, if we are still in Java 8, is move to Java 8 version 151. And with this version, we've got these flags. And notice that using this flag, use C group memory limit for heap, we are fixing the problem, because we are saying to the JVM that we do not want to take the bare metal memory, but we want to get the C group memory. And the C group memory is the memory that is used by any container. Okay, so now what's happening if I do docker build again, docker build, acquire my boot before, so I'm overriding the version. I do -f docker file memory. Okay, this is the file that I'm using now, the one that I am setting to JVM to use the C groups memory and not the bare metal memory. So now it just works. I can do a docker run again. Okay. So notice that now the output is fairly different, because it's, it's getting a lot of calculations, right, to get the correct memory. And now, of course, I can do a curl to sys resources, and you can see that I've got 100 megabytes of RAM and 4 cores. The reason of this 100 megabytes of RAM is because I've set it that I want to use 400, and Java by default is taken 1/4 of this memory. So it's just 100 and something megabytes of RAM. And of course, if I do now a curl and consume, notice that it works. I allocated almost all the memory, but the process is still alive. The reason that the process is still alive is because I have not gone beyond my limits. This is the reason why we need to take really care of the limits of our application and how they manage the memory. Okay, so let's move to Kubernetes to see this thing that we've seen here, but in Kubernetes. Let me stop Docker. Let's go here and let me show you first of all some slides, 2 slides here. Then with Kubernetes we also can set limits. Okay, the limits, you just said something like this. Resources, I want to request 300 megabytes of RAM and CPU to a quarter a core. Okay, this is a request. So when we are doing a kubectl apply or kubectl create, deployment and so on, what Kubernetes master does is find a node that at least has 300 megabytes of RAM free and 1/4 of core free. This is a request. This is the initial, right? This is the initial request. If there is no node with this request, then the pod becomes in pending state. It's just pending until one node has this minimal requirements. But then there is the limits. So also we want to limit how much memory can consume this pod. In this case, we put it that it can only consume 100 megabytes of RAM, so from 300 to 400, and he can go from quarter of the core to a full core, but that's all. He cannot use more than one core. And this is important because at the end, containers are about sharing and deployment density. Sometimes people think that containers are a way to isolate processes, but that's not true. Because we are isolating the processes, but this process at the very end runs over the rainbow, right? Over the CPU, and it's a physical CPU running them. And it means that we need to limit the amount of resources that they can use. Because if we said that one process can use all the CPUs of a container host, then there will be you will not be able to deploy more services on this host. For this reason, it's really important to make or limit the resources. So let's see it now. There is any question? No. Okay, perfect. Now let me deploy another service. I mean that the Spring Boot service again. kubectl minus oops, not here. Let me yes, it's here, but I need to move to another directory. Now see kubectl apply minus f apps q files my boot and my boot resource limits. Okay, now I'm just setting I'm just creating a service with some kind of limits. I can do kubectl get pods as usually. You can see that it's my boot application is running, and if I do kubectl describe pod and this my boot. Okay, now you see that it has been started, and somewhere here you say that I'm limiting to one CPU and memory, 400 megabytes of RAM, and I'm requesting a quarter of the CPU and 300 megabytes of RAM, right? So this is my pod. Now let me create now a service because I need to be able to interact with this service some way. So I'm going to do a kubectl apply minus f apps q files my boot service, which is here. Okay, and now let me show you the file as well. Meanwhile, while the service is updated, if you check my boot, these resource limits, you see here that it's more or less the same as before. I'm just saying that it's a deployment. I've got one replica. It's my boot, and the containers are my boot v1, container 8080, and I've got these requests, right? These limits and so on. Now, kubectl gets, kubectl get services. I've got this IP in the 8080. You can do a curl of this IP 8080. Well, it still has not been updated yet. Sometimes, as I said before, Amazon takes a bit of time. Let's wait a bit. Meanwhile, I can just open another. So we can have everything here. So at least you can see the pods that are running. Okay, and now I can even do while, and I will need to change this to the IP. Let's see if it works. Just to 8080. No, not yet. Okay, let's see if it works or not. If not, come on. No. Yeah, sometimes takes just 1 minute until the DNS is published. Services. Come on, Amazon, you can do it. Okay, well, then let's wait 10 seconds. Let me see if there is any question. No, there is no question. Okay, let me do the final. Now finally, okay. Now it's working. Again, this service, it has these sys resources. And if I do a sys resources, you can see that I'm using 2 GB of RAM and 2 cores. The reason of this is that my node, my Kubernetes node, has 8 GB of RAM and 2 CPUs. So just Java thinks that I've got 8 GB of RAM for him, so it's taking quarter of the memory, so it's like 2 GB of RAM, or 1.7 gigabytes of RAM. But remember that I've said when I did the kubectl describe, remember that I set it here. Let's see, that I've set it to 4 gigabytes of 400 megabytes of RAM. So what's going to happen if I do the call again with consume? Well, now important things that you need to see is this window. Okay, you will see here that this pod is going to be killed and restarted. Oh, I'm killed, running. So this is what happened in Kubernetes. In Kubernetes, you are getting an OM kill out of memory. It kills the pod, and since there is a replica set there, it just starts again the service. It comes to life, automatically. If I do kubectl describe of the pod, you will see here that, let me check, because there is here the last state, not the current state is running, but the last state is terminated OOM killed. So this is the reason why the pod was killed. And this is something that we need to always take care of this restart number. And if you see that these restart numbers are increasing, then do a describe and check what's happening, because probably you're getting this kind of memory problem. So you have not configured correctly your application regarding the memory that it can use. Okay? For that reason, it's really, really important, this section about resources limits. Okay, let's stop it now and let's, for example, start checking another thing, which is the liveness proofs and the readiness proof, which will help us to fix the problem that we've seen in the beginning, how we can do a rolling update with 0 downtime. So let me again delete everything. Well, I'm not going to delete everything. I'm going to leave the service. So we've got this host or this DNS name or public DNS name up and running. Kubectl delete my deployment, my boot, I guess, or my app, I don't remember. Good. Deployment. Okay, kubectl get pods. Okay, now it's terminating. So I'm just shutting down my boot service, but the service is still there. I mean that the Kubernetes service is still there, pointing to this IP. Okay, now let me show you one small thing, okay, and it's liveness and readiness proofs, and it's here. So now, not here, I think that I can close this, yeah, and now I can just do a cat and the apes, q files, my boot, live and ready. Now, what is liveness proofs and readiness proof? Well, basically, it's this. I'm setting my container, my resources, and then there is 2 new sections, liveness proofs and readiness proofs. Okay? So, what is the difference between liveness proofs or readiness proofs? Well, the difference is that liveness proof just checks if your service, your pod, is a zombie or not. And what it means zombie is that your pod is up and running, but it's not able to serve any request. So it's just there, maybe in a deadlock, maybe it's, full of work, it's just, overloaded, so it cannot serve more requests. Maybe it's just, it's, as I said, it's hung there doing nothing, but you cannot access. The pod is always, if you do kubectl get pods, you see that the pod is running, but is not able to serve any request, right? It's in a zombie state. This is liveness proof. Liveness proof is to detect this kind of stuff. And what happens when Kubernetes detects that your pod is zombie is stop the pod and restart it. But then we've got the readiness proof. Readiness proof is a different thing. Readiness proof it's used to know if your application is ready to start serving requests. For example, you can do you can start a pod, but when your service has been started, maybe you want to do some kind of synchronization. For example, you want to update your in-memory or your distributed in-memory database, or you want to apply some kind of schema updates on your databases, or you want to synchronize with other services. So although the project that your service is up and running, you don't want to send any requests yet because you are doing some kind of operations before getting ready. And this is the readiness proof. The readiness proof just makes your service, or makes Kubernetes not sending any request to your service because it's doing something. Let's see this in action and probably you'll understand it better. Let me do first of all the next thing. kubectl apply -f apps kube files and deployment. This deployment file, I can just get you, has no, it's the original problem, and has no liveness and readiness proof. This is the example that you've seen at the beginning of the session, right? So I can do kubectl scale to replica 3, and now kubectl get pods, and I've got 3 pods running. It's going to start it sooner than later. Okay, then what I can do here is this. Let me kill this now. And I'm going to do here a while, true, blah, 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 blah. So I'm just getting aloha. Okay, now I'm getting exactly the same problem than before. Okay, let me say if it's scale up to 3 instances. Not yet. Probably the problem is that this node is, that this pod is scheduled in a node that does not contain the container image, and for this reason it's taking a long time because it's downloading the container image, which is like 300 megabytes or something like that. Okay, now everything is running. Remember that if in the initial example, when I updated to version v2, you get it some kind of downtime, right? Now let me do exactly the same thing, but using the liveness proof. Okay, so I'm the liveness proof version, apps kube files, my boot, and here it is the liveness. My boot, liveness and readiness proof. Okay, I'm just doing exactly the same, but now I've got the liveness proof and readiness proof defined. And now notice that I'm not going to see any downtime here. I can do a watch of the pods. Notice that one pod is still here. It's all of them are running. Okay, it's waiting a lot. Okay, it's not yet sending any traffic, and now it's starting and all the rolling out update. Okay, notice that how it's changing from one pod to another pod, but there is no downtime yet. Okay, you'll see it in a moment that I'm just changing from one pod to another pod without getting any downtime. Notice that here this is the new pod. This is new one. Notice that this is a 2. But there is no downtime. Okay. It's just taking a bit of time. That's true. Notice this is a new one. Notice that here is a 3 and 4. So it's coexisting both of the services, but there is no downtime. At the previous version, the thing that I've showed you at the beginning of the master course, you see that there were downtimes. The reason was that because I was updating from one service to another service without any liveness proof and readiness proof. But here, since I'm using liveness proofs and readiness proofs, the transition happens smoothly, right? It's happening without any downtime. And that's really important. So when you start using Kubernetes and creating your deployment files, remember to set the resources correctly, because your pod is going to run with other pods in the same machine. And second, define correctly your liveness proof and your readiness proof to be able to update your services in a correct way. But okay, now that we've got this, let me show you exactly with a concrete example how liveness proof and readiness proof works. Let me scale down, scale down to 1, just because it's easier then. This is the pod that it's working correctly. And now I can just do kubectl exec -t. Remember that kubectl exec it's used for going inside the Kubernetes class, the pod, the container. So I'm just inside the pod. I can just do ls, and you see that there is this jar file. And if I do a ps -f, you can see that it's where I'm just running my java -jar process, right? This is inside the container. Now, this, let me show you the code so you understand exactly what I'm doing here. Because I think that you will understand better. Let me go to the apps, Hello World Spring Boot, and if you check here the REST controller, you will see here is the sys resources, the one that returns all the resources, that consumes. Oh man. Okay, now consume, and now I've got here another a method which is called health. This method is the one that is used by the readiness proof. Okay, readiness proof is just doing a call all the time to 8080/health. Let me do a -bb, and you can see that now I'm just saying I'm fine, thank you, and return HTTP 200. Okay, for this reason, kubectl get pods, this pod is running, because every time that Kubernetes goes to /health, it returns a 200. Okay, now if you see the code here, you see that I'm saying if behave, return okay. If not behave, then return bad, service unavailable. How can I do this? Okay, I can just do a curl localhost 8080/misbehave. Notice that it's saying misbehaving, and now if I do a curl localhost 8080/health -bbb, you can see that it's saying 403. Okay, so it's saying that this pod is not ready to serve request. Okay, now what's happening if I do kubectl get pods? It takes a lot of time, but notice that it says a status running, but it's 0-1. Instead of 1-1, it's 0-1. This is happening because my pod is not ready to serve requests, so I cannot send any request to this pod. In fact, I can do a curl. Oops, let me change this to this, and notice that it's just hang there, and at the end it's going to send a timeout error because there is no pod able to serve my request. And the reason is that this pod is not ready because his readiness proof, it says it returns a 500. Now, if I'm going here and I do curl localhost 8080/behave, and notice that I can do again this health, and now it's returning a 200 again. And if I do kubectl get pods, you see that now it's running and it's 1-1. Okay, so now the readiness proof, the Kubernetes did a request to /health because this is what the readiness proof says, and it says okay, now it's returning a 200. Then it means that I can start sending requests. So now I can do a curl again, and it's just working, and I can do the scribe pod And notice that with the describe, you will able to see also the status, which is here, or somewhere over here. Bam, 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 bam. I cannot see now. Okay, here, running and without restart and ready. It's true. If not, this is false. Okay, if the health of the readiness proof is not returning to 00, then this is false. It means it's not ready. And here, I don't know if, yeah, here you see here the liveness proofs. I'm saying that there is a liveness proof and I'm saying that there is a readiness proof. And as I said, the readiness proof is at 8080/health. Okay? Now, hope that it's clear how this readiness proof works. Let's see how liveness proof works. Let me see if there is any question. Probably Sebi has done a really nice job, but can it be done if doing network migration as well? I think so. I think that it works as well. Christopher, you're asking me about the network migration. Yeah, I think that it works as well. If you define the readiness proof and the liveness proof. I am Bhaskaran, you are asking me if the status is terminating, is the new pod will be created of its own? Well, actually, who is creating the pod is who is detecting that the pod is terminating is the deployment, and then the deployment that is running inside the node in the kubelet will spawn a new pod. So it's not that the pod that starts by himself, but it's someone who detects that the pod is terminating and then started again a new pod. Okay, perfect. Now let's see the liveness proof. Let me do a kubectl edit of the deployment my boot, and let me change one thing. Let me change the liveness proof to one special liveness proof that I've got out there. Wait, maybe it's up. Bum, bum. This is the readiness, this is the liveness proof, and I'm going to change this to a /alive. This is a special endpoint that I've created so you can see what's happened when the liveness proof is not working. I can save this. Of course, now I'm just getting a new deployment. Notice that this container is still running, and then there is a liveness proof and readiness proof, so this is not terminating yet until this one is running. When this is running, then this is terminating. You can, I could do a watch. Look, notice that now this is running, so this one is terminating. Before using the liveness proof and the readiness proof, what's happening was that one pod was terminating, meanwhile the other one was starting. In this case, one is terminating when the other one is running. Okay. Now, let me get pods. Now, let me put here a watch kubectl. Let me put the watch here, and I'm going to do a kubectl exec -t of this pod that is here up and running /bin/bash, and let me go again to the code and notice that this alive. Remember that now my liveness proof, it's not going to a slash, it's going to a /alive. It's saying that if not dead, returns an OK. If not, returns a 400. Okay, or 403. Now, of course, if I do call localhost 8080/alive, it says that it's alive. Remember that now the /alive is the liveness proof. It's not the readiness proof. In fact, we can just do a describe of the pod, and you can see here that the liveness proof now it's in a /alive. Okay, this is really important. Let's go again with the watch. Now, what's happening if I do call localhost 8080 shot? Basically, I'm saying I'm shooting this pod, right? I'm just basically it's funny thing, but I'm just saying that it's dead. Okay, I'm killing it somehow. I'm just putting dead equal true, and now the liveness proof is going to return a 403. Okay, I'm just going to do a shot. Notice I said I've been shot in the head. I can do call localhost 8080. See this bottom terminal, the restart is 0. Okay, so at this time nothing has happened yet, but I can do just curl in alive, and you see that localhost. Notice that it's saying that I'm getting as 403. Now this is still running. The reason that this is still running is because when you define a liveness proof and readiness proof, you set the period of time that you want to execute this. For example, you want to execute it every 15 seconds, every 30 seconds, every 5 seconds, and so on. Notice that now I've been killed because I'm not in my pod anymore. Notice that it says command terminated with exit code 137. So I've been killed. Notice here, this is the output of the process, and the restart is 1. This happened because at the end the liveness proof failed, and since it was a liveness proof failure, it just killed the container. This is the big difference between liveness proof and readiness proof. The liveness proof killed the container. Notice here that they've got 1 restart, and the readiness proof is just park the pod until it's ready to serve requests. Okay, this is the big difference between liveness proof and readiness proof. If you do, I do a describe again. Let me do a describe again so I can explain you another thing before we jump to the config section. Notice that here I'm just saying delay 10 seconds. So I'm just saying that I want to execute, in this case, with a delay of 10 seconds, I want to execute every 5 seconds the liveness proof. So every 5 seconds, Kubernetes is doing a curl or HTTP GET to a live endpoint to check if the service is live or not. Okay, that's all for the liveness proof and readiness proof. Let me delete deployment my boot, and let me check if there is any questions. No, there's no more questions. Okay, perfect. Now let's go to ConfigMaps. How we can configure our application. Okay. Let me again deploy apply -f apps Q file my boot deployment. Remember that my boot deployment is just a really simple application. And one of the things that you need to know is that when I'm just doing this slash here, I'm getting the greetings from an environment variable. Okay, I'm just reading the greeting environment variable, and then I'm just returning. Okay, so I can do a call to this. I'm just getting aloha, and the reason that I'm getting aloha is because if I do kubectl get pods, I can do kubectl exec -t of this pod. And if I do export, you can see here, well, there is no greetings. Okay, there is no greetings. And if there is no greetings, then I'm getting a jumbo, right? And I'm just getting aloha. And I'm just getting aloha now. Wait. Oh, I'm missing something now. Greetings. I grab. Okay. Interesting fact. I call. Yeah, I'm getting aloha. I'm just trying to figure out where this aloha comes from. And not jumbo. Probably I'm missing something somewhere. Maybe in the deployment. Wait. Kubectl describe. Oops. Scribe. Pod. Let me check, because maybe I missed something right now, but no worries. For the example, it's going to work as well. No, there's no environment variable. Set it, and it's getting aloha. Okay. Yeah, what's happening is that the code and the Docker image is not the same. Okay, so I mean that what's happening with the version 1, now I remember that the version 1 of my boot, remember that here I'm just using my boot, wait, what is, the container image is here, my boot v1, it's returning aloha by default instead of jumbo. Okay, this is the thing. Okay, now this is the default. Then what can I do now is just set an environment variable to change this value. Let me do a watch of the show levels, and now I can do kubectl. Kubectl set amp in deployment my boot. I want to change the greeting environment variable to namaste. Okay, and now notice that here, now I'm going to read greetings, and there will be an environment variable, and I'm going to return namaste. Okay, now what's happened when I do this? It says that the environment variable has been updated. Okay, and notice that my boot pod is terminating and it's running another one. The reason that it's happening this is because you have changed the environment, you have changed the pod. So you need to terminate the current pod and start a new pod with the change that you have applied. In this case, it's this setting this environment variable. So now I can do a curl again, and notice that I'm getting namaste. Okay, this is how you can configure from outside your application, just doing kubectl set amp, and you set the environment variable. Of course, this is not, let's say, the best way to do it, but it just works. Let me show you another way of doing it. Let me delete this deployment. Okay, and now let me show you how you can create a config, right? A Kubernetes config. I can just do a kubectl create config map. I'm just creating a new configuration resource. Okay, this is something that it's inside the Kubernetes. This is a Kubernetes resource. I can do give a name, my config, for example, my config, and for example, it's from amp. So I want to create some kind of environment variables from one file. File, and this file is at apps config application.properties. So now I'm going to from Kubernetes. It's not config. Wait 1 second. ls apps. I can do it in a config. Yeah. Some properties. Okay. Config / some properties, and I'm in config, so I can do it in this way. Okay, now let me do, I'm creating a config map. A config map is a resource of Kubernetes that basically it's a configuration that then you can reuse in your pods. If I do cut in some properties, notice that I've got greetings, Jumbo, love, amor. So basically when I'm doing this is creating a config map from these files. Okay, and basically what's going to happen is that when I start a new pod with this config map set, it's going to use these as environment variables. So I can do kubectl describe config map. I call it my config. Okay, and notice that I'm just getting all the information from the config map. I'm getting the greeting, Jumbo, love, amor. Okay, this is a config map, nothing else. Now, what's happened if I want to deploy a pod that uses this config map? I can show you the file. My boot, my config, it's deployment configuration is this one. Notice that I'm just saying that I want to use as an environment variables all the config map that it's coming with the name my config. So I'm just saying in my pod, notice that I'm setting the resources again, the container, and here this is a special section which I'm saying take the config map values and set them as an environment variable. So I can just do kubectl apply -f apps kube files my boot configuration. Now we are almost running out of time, but this is the last example. I can do kubectl, well, in fact I can do a curl, and notice, oops, not yet, come on. Now notice that I'm getting Jumbo and I'm getting Jumbo because this config map has greetings Jumbo, so I'm getting Jumbo. And if I do kubectl exec -t of this, and I do an export, now you can see here now that there is a greeting with Jumbo, and probably there is also the love amour. Okay, so this is how you can, or this is one way of configuring the Kubernetes pod using the config map. Of course, you will say, yeah, but you are still using environment variable. You can also make these properties, this kubectl get cm my config, make this thing. Let's see if it just starts. Okay, I would like to do the scribe, sorry. Oh, I could put this as an environment variable, or I could put this as a file. So instead of setting as an environment variable, you could set this as a file, which the name will be greeting and the value will be Jumbo, and there will be another file called love and the value will be amour. Okay, so you can inject as files or inject as environment variable. This is up to you. And that's pretty much everything. Yeah, this is saying that the v1 is not pointing to Aloha, yeah. Then I think that we have done everything, Liveness, environment, config maps, everything. Yes, then remember that we've got these books that you can download it for free in developers.redhat.com. There is the Istio book that next week we've got the session. We've got microservices for Java developers, Kubernetes patterns, if you want to see a really nice pattern for Kubernetes. Some of them are from easy patterns, other one are like high-level patterns. So yeah, there are some that are difficult, others are easier to understand. Knative cookbook if you want to go to the serverless Kubernetes, and migrating to microservices databases as well. And that's the end. Let me put again the tutorial so you can just replay everything that we've seen here. Hi Krisam, the rest. And I think that's pretty much all. Thank you very much. If there is any question, I will wait here just 1 or 2 minutes because I know that there is some delays between what I'm doing when I'm speaking and what you are listening. So I'm waiting here 1 minute or 2. And if there is no more questions, remember you can do it by email, questions by Twitter. And remember that next week Kafka and Istio is really interesting master courses for you. Thank you very much.